Section 12-2, Pythagorean theorem. In a right triangle, remember a right triangle has a 90-degree angle, and the 90-degree angle is denoted by the little box here at the vertex. In a right triangle, the two short sides, these are your two short sides, the two sides that join to form the right angle are the two short sides, and we call these the legs. The longest side, which is opposite the right angle, is the hypotenuse. So the hypotenuse is the longest side. And these two sides, the legs, are the shortest sides. Okay? So it doesn't matter how a triangle is lying. It could be lying something like this. This is your hypotenuse, because this is your right angle. Your hypotenuse is the side opposite the right angle, and this side is a leg, and this side is a leg. These are your two short sides, okay? You can represent the lengths of legs of a triangle with A and B. So your legs are the A and the B. You could just as well have B right here and A here. That's okay, but your legs are the A and the B. And then the length of the hypotenuse, which is the side opposite the right angle, is C. C is always your hypotenuse. It's always the longest side. A and B are the legs, and they are the shortest sides. In any right triangle, the sum meaning to add, the sum of the squares, meaning to square something, multiply it times itself. The sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. I'm going to read that again. In any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. This equation is known as Pythagorean theorem. Leg squared plus leg squared equals to hypotenuse squared. Remember, your legs are the A and the B. So you have A squared plus B squared equals to C squared. This is the Pythagorean theorem. You can only use the Pythagorean theorem when you have a right triangle. Okay, that's the only time. And you will use the Pythagorean theorem to help you determine lengths of sides of your triangle. So let's look at part 1 here. In part 1, it says you can use the Pythagorean theorem to find the length of the hypotenuse of a right triangle when you know the length of the legs. Example, finding lengths of hypotenuses using the Pythagorean theorem. So here we have a triangle, okay? What is the length of the hypotenuse of each triangle? So let's look at A part. We're given a triangle here, a right triangle. We're given the legs is 3 centimeters and 4 centimeters. We are missing the hypotenuse, which is C, okay? So I'm going to let A equal to 3, and I'm going to let B equal to 4. So let's use the Pythagorean theorem. So I have A squared plus B squared equals to C squared. So my A is 3, so that's 3. I'm going to put parentheses around it squared. My B is 4. 4 parentheses around it squared equals to C squared. All right? So squaring, using your exponents first, 3 squared, that's 3 times 3 gives you 9. Plus 4 squared is 4 times 4 gives you 16, equals to C squared. 9 plus 16 gives you 25, equals to C squared. Now, to go from something squared to something not, we will take the square root of both sides. So we need to take the square root of both sides. The square root of C squared is C, equals to, the square root of 25 is 5. When you take the square root of something, you're asking yourself what value times itself gives you 25. Well, that is 5, okay? Now, we only would get positive. The length of sides of a triangle is positive. No such length is negative. You know, normally when we take the square root of both sides, we could get plus or minus 5, but you only get the positive square root because lengths of sides are positive. Therefore, the length of my hypotenuse of my triangle given is 5 centimeters. And we found that by taking the square root of both sides. And the square root of 25 was 5, therefore we found the hypotenuse to be 5.